Welcome back to my channel. This is my face first. If no one here, I can show my face here. See my face here. I'm currently doing this kind of processing on the board, but this is what I'm doing today. But here, you see on the right side, I've got the blue chalkboard. But literally, the blue is basically my memory, my mnemonic. It's like, I'm organizing my life. So, doesn't matter the space I have a processing. This is a processing area, the blue, and all the chalk in blue on the, obviously, I divide the board into a third, a quarter. So, a quarter is just for blue, and this blue is a quarter of the whole board, the whole processing space. So, 3/4 of the space is, I just use a quarter. I don't even use a half of the page to process it. I use a quarter, and this quarter is divided in base times height. So, basically, the base times height of the board is literally what needs to process information. Because anything that comes up just goes here automatically. For example, as a policy now, the N for November, S for Sarah, I for India, G for golf, I for India. NSIGGI University by me, OB Nexus Namdi. Because OB Nexus NSIGGI University, this is human rights university. So it's specialized in human rights. It's my university. So it's my university, human rights university. In basically, it's gonna be in all of Biafra, all of Newi, Anambra State. It's gonna be decentralized and localized, but it's a human rights university because it's it's really a constitutional bound human rights and system for humans who actually want to work. People don't want to just work. Down. So it's human rights university for people who want to work. So all the breakthroughs should be coming out from there. Because I'm sovereign. But if you guys really want to be part of it, the NSIGGI University is there for you to be part of, to work, and you can get the off time off work. So anyone can walk there, can go there. If you can walk there, drive there, you can go to university. There's no money involvement. And if you want support to get there, and you're disabled, you get support. But you have to have a broken leg or something. So that's the policy, a very policy there. So that's what I'm saying. So NSIGGI University is the first memo. It's called a memory mnemonic. So it's like a sticker. Another example is like a sticker board. So this was a hard memory mnemonic. It's on a board. You got a sticky note. Where's my sticky note? So I have a sticky note in my wallet, but I don't want to bring it out. But I don't know what it says. I'm gonna bring it off camera. So the sticky note says this. So I have a sticky note in my wallet here. This is my wallet, by the way. Such a nice wallet. Such a wallet, but it's a good wallet, I keep everything in there. But it's basically so I don't have time for that. But so the next one is symbolic and trident consensus system. So basically, you remember the symbolic interpreters, which are interpreted languages. That's really part of the policy today. But it's basically in real policy, you don't have AI first. You have symbolic interpreters. So symbolic interpreters interpret the state of a system. But so basically that's what you're using to find meaning. That's the early form of AI and the venom. Because there are models that that metaphor files uses to find meaning in hidden data, interpret the stuff so you can get what you need. Do you mean this? And that's actually what I'm working on today. But it's basically this big thing here. But it's basically called, I'm working on perceptive membranes. So they're related to perceptive membranes. You get this one here. For example, you have OBI speaks Igbo. Ebo, Echo, E for Echo, English, B for Bravo, O for Oscar. Uche speaks French. French. And Eze speaks English. Eze is English, So you can continue to people. For the perception of language is what matters. So this is the perception of language. So I can start speaking English, but it's a language. I should speak the language to that person. For example, if you're speaking French, I will speak in English. We can't communicate. We can't use the protocol. So you can't use the secret protocol. So so it's basically meant to be a safe space for people to use the protocol safely and do what they want to do. And have freedom of information and do what they want to do. I believe in Coca-Cola. But I don't have proof for that, so I can't say that. So what I was trying to prove today was literally this perceptive membrane double the space for half the time to process information. But that's what it's perceptive membrane. The goal is to store this result, store what you remember, get some clean information. And this was my math so far. So my math so far is basically half times base times high, base of 3. Now, base of 3 refers to x, y, z axis, dimensions axis. You use base of 1 x, y will be x2, and base of x2 is 3. So b3 refers to x, y, z. and you get times height, which is the height of the system, but the shear height. So you get half times base, which is just this is the area of the shear, a triangle. But this base is in three lattices. Really, they have a projection of a vector. So where you get projection from is where you are. So basically, my theory was basically perception isn't evolutionary. You don't evolve perception. A perception is basically a frame of reference, from the problem. So you have an angle here, 45 degrees, 45 degrees, and 45 degrees here. But the 45 degrees means that you are have an angle there. So I'm going to show them how basically I have to try to get order my lunch today. So get 45 degrees angle in a right angle triangle. No, in a equilateral triangle. So the 45 degrees is basically every pathway you take, so you can perceive that gives you meaning. But I'm going to do it dynamically. So I have to know that I hold this place is held for me. So how can I measure something dynamically? How can I sketch like a sketch diagram? What can I scatter? No, but this is not scatter. This is not scattered. We're processing something dynamically on a lattice, which is basically the union of information via basically this is a lattice model here of perception. I've got so you got a union U, disjoint union and intersection of this framework here. So the angles is more important, but I won't go to the proof today. All I'm saying to you, you got forward and backwards. Or for my forward is your backwards, and vice versa. On a 3D grid, because it's base 3, half times base 3, base sub 3 times height. And this equation here. So you get bxy, and you have for bxy, you get forward and backwards, you get up and down, and you get left and right, which is called the matrix dimensions. So you have the pathway, matrix path. You can call it the dimension, matrix pathway. So let's call this one pathway. That's D, P. F, the matrix that contains F or B in the x coordinate system. U up U sub U mean F before or B forward or backwards, U or D up or down, L or R left or right equals P, the path the old style take. Union the rotation theta sub x, theta sub y, theta sub z. But they have it's not complete yet, but they have the property of the shear property that you can also manipulate, displace. This is called displacement property. Displacement. So displacement property. So displacement property for the union can let you move. So you get big D sub big D input of FB input of big D input of P union R, basically big D union R is all the displacement of the pathway union the rotation. So this is pathway and rotation. So you get pitch sub theta sub x, which is basically the pitch of the system. Theta sub y, which is the roll of the roll. No, so basically theta sub x is the roll, like rolling like on axis of x, on axis of x. So theta x is basically theta x on the first matrix is roll. Theta y is pitch. Roll, pitch, yaw, and theta z is yaw. This is basically what Game Boys use to lock on the to rotate where you move. This was system use of Game Boy. On Game Boy, what we call a Game Boy axis. What I call it Game Boy axis, but that's what I'm saying. You go D sub U, dp du, and they work on 2 pi r over 180. And 2 pi over 180 for the pathway, because the 80 degrees, 90 degrees is basically an intersection. 90 degrees is an intersection, between P and R. But the goal is every pathway you can take is a pathway P. There's a rotation. There's a union. There's a union R. PR. There's a P or union. There's a P R and PR pathway rotation. Every pathway shape and form you can take. The pathway or roll pitch basically on polar axis. The pathway. There's an you have to have a rotation, so you can have like a rotation rotation, which is like 45 degrees, to observe to get information, 45 degrees, and you get 45 degrees 45 degrees pitch displacement. You get displacement property that can give you you get a disjoint set. So, example, I'm trying to do it properly now. So, so you get so if you have an angle for 7 degrees, which is off axis, basically. Off axis by 2 units, so you started from dimension, you are started from 45 degrees, and you have point A is a 45 degrees, it's a 45 degrees. It's a basically this I'm saying I'm claiming that this triangle system, because you can have all relative axes. So the kind of thing you can get with the system is one, threat modeling. But how to do it properly? So you can get threat modeling with this thing. So you get, let me try to do it properly. So you get x squared plus y squared equals t squared. But you get the parabola equation y equals negative by plus or minus square root of b squared minus 4ac over 2a, and you get something like here. So you get y parabola equation, but x and y, and select the parabola and the space. This is basically called a time capsule, a space capsule, when t is time and y space. But how this works, so you can have a relative time. You have a relative time. So basically, this is like we go more fact. You get Planck's constant. So Planck's constant. You get Lorentz factor, which is 1 over t, 1 over something else. So this is basically what you plug in, and it should resolve each point in space. Basically, the point in space of x, y, z, where of the base have a base, and the base is the foundation of the system. But the phase is dynamic, so it's a dynamic base. So the goal of this is basically, for me in my next video, to show you how to use this Lorentz factor, which is time, and the dimension, which is space, the space around it. But the space is defined as a polar grid, a polar lattice, a polar coordinate lattice, and that's basically the disjoint property. So you can have everyone know where they are relative to one another, but they have both absolute coordinate system, so they have a fixed position, or a dynamic coordinate system at the same time, like a Mach and Drake system. So I know this threat modeling, modeling threats of a tomographic system. Have you got a knife? Have you got a kitchen knife, or have you got a bread knife to cut? Did I give you the right knife? Are you wearing the baggy clothes? And do you have a gun underneath your vest? I'm saying a bump underneath your vest, or do you have just a regular vest? That with some kind of padding, some kind of So have you doubled your vest? What type of thing you wearing? Do you have a pen, or do you have a pen that contains lead that's not been distilled into poison, or poison pen? So basically, that's which is a poison pen. So I have a poison pen. So the lead is poisonous. So that's why I'm saying it's a poison pen. So so I'm gonna upload this video now. But the goal of this is basically to have a system that has a dendrite model to dictate things like threat modeling. For real-world scenarios, via computation of lattice. So the point A, B, C are where people are on this grid, but the formula is defined mathematically. We go with the formulas here, but this is like a real-world system of a consensus framework. Because in the fake world, say you can have x squared plus y squared equals t squared, which is the time, but t is a Lorentz time. It's a Lorentz factor of time in space. So the Lorentz factor has to split into space, time into space, or space into time. So what I'm saying to you is the dendrite has double the time and half the space, or half the time and double the space, which is log n, and log n time, and log n time over double the space, n log n time to compute, and n log n and m. n squared time maximum to compute, because n times m will give you n squared. So the time will be time first will be n log m or log m minimum time maximum to minimum 2 over divided by n or n squared, which is basically the linear time bound by the logarithm or logarithm linear time ratio of half time to half space and vice versa. Okay, guys, like and share this video if you like it. But the proof is basically, again, x squared. X is basically any input of the x-axis. So you can have row picture of the x forward and backwards. Anything that you have, anything that's called an x, anything that's x forward and backwards. So you get x, you get forward and backwards. This is x-axis. So you get forward and backwards, which is basically a coordinate system of polar of Cartesian. We can have this as rotation or 45 degrees angles here of the triangles. You can have this as any of one coordinate system of a homogeneous only or heterogeneous coordinate system that depends on the sensitivity of the system. Basically, what it determines like a charge system. But this really makes it more sense to see input devices or sensory artificial, detect whether to act. So basically, if I have my right hand, right, I'm right on Entrepreneur's Road, on my right hand, my right hand here. But this right hand is my reality, I'm right on my right hand, but I'm perceiving with my left brain, I'm left brained. So it's basically I have a context switch for the language. So this is the context switching basically says if I'm speaking French and you're speaking Spanish, we can both switch. If I'm speaking French, like bonjour, je m'appelle Namdi, je viens sing okay, sorry. Je m'appelle Namdi. Je viens 5 ans. Basically, I'm 25 years old, but je viens 4 ans. I'm 24 years old. But I'm 25 because I'm Obi. So if Obi says that I'm 25 years old, which Obi is 25, then Isaac will reply, why? Isaac will be confused. So the goal of this is to have a context switch. So the context switch is basically a language transcriber. But, they have to agree on what they share, and that is the language. So Isaac replies as I am in English in his way, but this is for accessibility. So this condition is for accessibility. So condition for accessibility will make sure that the person. So as you reply, oui, je 24 ans, that means I'm 24 years old. I'm 24 years old, I'm 24 years old. And then, but if he doesn't know French, he still say I'm 24 years old. But they cannot interpret, but the dimension is language. The dimension is the operator is language. But the conscious switch has to apply for the perception. So, because the consciousness is disjoint. Consciousness is disjoint. It's disjoint. So consensus has to be disjoint. Because we don't need language. We don't want to start learning a new language. We want to increase our accessibility. And then when Uche comes in, he will say, I don't say yes. You don't want Uche to transcribe. You want it to just picture it. So there's no transcriber here. You have a context switch. Context switch is basically a parser, Alexa that it's a parser that can switch Alexa before the system you can switch to Python or JavaScript or Node.js. Interpretation of the system. Handles the best case, worst case. Because if I'm talking in Python and something's interpreted in JavaScript, I don't know what the binary is. I don't know what you go to pickle files in Python. JavaScript cannot interpret pickle files, so they have to translate. What's the context of the system? What is the context? What am I trying to interpret? So the context which allows for you to do jobs based on the current artifacts. You have standard JSON files, but pickling takes a JSON object, any object, and creates a Python representation of the dictionary. But Python has a target assembly language, and that language can control to JavaScript, and that's JavaScript control. So JavaScript has to take the assembly file of JavaScript has to take the assembly file of the context of Python, whatever the pickle file was, and then run it its own native way. So that's basically what we call web or web assembly to text. What to what some. What's some to what? Thank you guys for watching. This video has been interesting. Good. Have a lovely day, and take care of yourself. So we covered context switching, for language, and then Uchi would say, like in Igbo, Kedu Afomu Bunamdi, and I am 24 years. I'm 24, and I don't know how to say that in my language. I'm 24 years old. In Igbo, in If Echo, B for Bravo, of Echo, which is Ebo. The Igbo language. So you can say Igbo or Ebo. Asusu Igbo means I speak Igbo. So but you have to determine the language. You have to start determining the language, because the language determines the dimension. So if AJ is speaking French, you have to determine one language to speak. So you have to speak one language. So you can speak. That's what I'm saying. You have to share a common canonical interpretation of the system. And that is the language dimension. So the language basically represents the dimension that it operates on, and the dimension of the why. Basically, if you come to a space and speaking French in an English class, no, you can't do anything. You cannot act on it. So that's why the system works the way it does. So but you get discriminated against. So it's accessibility that can never discriminate against you. It can never ever discriminate against you. Because it's not designed to. It wasn't designed to discriminate. So this video together. So we covered my memory mnemonic on the right hand, and we covered my UNI University dendrite models and symbolic interpreters as symbolic interpreters, as language interpreters, and we covered my y equals n minus b plus or minus square root of b squared minus 4ac over 2a, and then we have half times space times height, and we have s squared plus, and then we get t squared, which is Royal factor on the other side. Thank you guys for watching.